phosphorus enters wastewater from various ways. Plants, animals, and soils contain phosphorus. Too much phosphorus causes excessive growth of algae. When algae dies, it consumes oxygen in the water that causes fish kill. Therefore, most wastewater treatment plant permits contain an effluent phosphorus limit that needs to be achieved before discharging into a water body. Chemical and biological phosphorus treatments are true treatment techniques for removing phosphorus from wastewater. Chemical treatment involves addition of metal salts to react with soluble phosphate to form a solid precipitate, and then this precipitate is separated, dewatered, and disposed. Biological phosphorus removal involves PAOs, phosphorus accumulation organisms, to remove phosphorus. Struvite is magnesium ammonium phosphate. Struvite is well known for plugging pipes and fouling pumps, aerators, screens, and other equipment. This presentation will show how we could reduce or eliminate struvite formation and recover a valuable resource that could be used as a fertilizer in the field. The recovery process will eliminate the racetrack effect of recycling phosphorus within a wastewater treatment plant.
In a typical wastewater plant that is treating phosphorus biologically, a lot of the phosphorus gets stored in the biomass and then gets sent to the solids handling side of the plant in the waste activated sludge. And some of this phosphorus that's stored in the biomass gets released during digestion, and so when you're dewatering, it actually returns to the headworks with the return stream. So what can happen is you can end up with this sort of racetrack where the additional phosphorus loading that's coming back in that return stream ends up being too much for the process to handle. It can cause the effluent phosphorus to spike and potentially even miss the permit limit. One way we can stop this racetrack effect with the phosphorus is you intercept the side stream, that return stream, and you recover the phosphorus. Typically it's going to be in the centrate or the filtrate. Using these technologies, the typical recovery rates can be in the 80 to 90% range. So they can really significantly reduce that loading that's coming back in the return stream. Two manufacturers that actually have installations in the US are IKEstracts and Multiform Harvest. There's some difference between the two manufacturers, but both do use a fluidized bed reactor to precipitate phosphorus out as struvite. And then to allow for this precipitation, sodium hydroxide and magnesium addition are usually required. So the flow from the high phosphorus return stream is combined with the sodium hydroxide and the magnesium at the bottom of that reactor, and then as flow moves upward through the reactor, the struvite forms, and then the heaviest particles, as they're growing, they kind of go to the bottom of the reactor, and that's where they're recovered. So the low phosphorus effluent ends up going out the top of the reactor, and then the phosphorus as struvite comes out the bottom of the reactor. And then depending on the manufacturer, an internal recycle might be required. In terms of the finished product, the resulting pellets from that IKEstracts process, they're actually ready to sell. They call it the crystal green fertilizer. And then from Multiform Harvest, the finished product is a raw form of struvite. It's got kind of a sandy type consistency, and that gets processed into fertilizer or other products off-site on the secondary market. For plants that have problems with struvite buildup in the digester, one step that can be added is you promote the release of that phosphorus prior to the digesters, and you send that phosphorus directly to the fluidized bed reactor and bypass the digesters completely.
In summary, phosphorus in recycled stream can cause issues. By recovering phosphorus, we recover a resource rather than treat and waste. We reduce struvite buildup inside a wastewater treatment plant. Potential return of investment over life cycle.